Alright, welcome back everyone. I've got a few housekeeping things to talk about and then I'll jump into the math for this week. First of all, just thank you for the participation that I got last week. I heard from almost everybody and I'm really proud of that. Make sure you're aware that you must complete both of the assignments to receive credit for the week. Last week that was a survey and a math assignment. This week it is actually 2 math assignments. Also, just like last week, you're going to be expected to turn in the math assignments by taking a picture of your work. By the way, I do really need to see your work on there. If it takes any work to get to your answer, I want to see that in the picture that you're taking. If you cannot take a picture, please let me know. I do have an alternate way for you to submit it, and we can take care of that pretty easily. I just have to know. If you are confused about something, please take the time to ask me a question. I had some people turning stuff in last week and they were like, oh, well, I still don't understand half of this, but here it is. Okay, that's not super helpful. Go ahead, before you turn it in, email me. Be like, I'm really confused about these questions. Could you help me out? And I will totally make sure I can help you with that. And then, make sure you're reading the comments that I put on there, okay? I am giving feedback to every single assignment that everyone turns in. Especially if there was some kind of misunderstanding you had in doing the work, then it's super important that you're reading that feedback that I'm giving you. So if you submitted anything last week, it should already have a comment on there, so go on, make sure you can find those comments, because for future weeks, that is how I will be communicating. And then lastly, everything we're doing right now, guys, is for the sake of your learning. I've had some people concerned about, am I going to learn everything I need to know for next year? If you're keeping up with this, yes, you absolutely will. Now, if you're just kind of trying to do the bare minimum to get by, I highly advise against that, because there's really no need to just get by, okay? You've got time, you've got resources, and you're able to really spend some time learning some things right now. And again, I'm available for questions. Please use that. Alright, here's some math. I'm going to do a little bit of background on some things that we have already done this year before jumping into it. So for instance, if I write 5x plus 3 equals 18, this should look pretty familiar. This is called an equation. I was able to get into my classroom last week, get some supplies, so hopefully this helps. There might be a little bit of a glare on here. If you need to pause it, you can do that. That's what's nice about videos. So that's an equation. We know it's an equation because it has an equal sign and something that we can solve for. This, on the other hand, if I do something like 8x minus 4, that's called an expression. Okay, and no, I'm not quizzing you on the difference between the two words. Just making a point here. Here, this one does not have an equal sign, not an equation, just an expression. Alright, now, a term is just one little piece of an equation or an expression. Okay, so for instance, in our expression here, a piece is going to be broken up by adding or subtracting, or an equal sign. So here, this 8x, that's one piece, one term. And then this minus 4 is another term. If you have a minus in front of something, you do need to include that, because that means that term is negative. So we've got an 8x and a negative 4 as the two terms in this expression right here. Up there, you've got 5x as a term, positive 3 is a term, and 18 is a term, okay? And that's just pretty much another word for piece. And the last thing I wanted to find, this one's new. It's called polynomial. Okay, now you might recognize that prefix poly from like polygon. A polygon is a shape with multiple sides, so a polynomial is an expression with multiple terms. Okay. Again, if you need to pause that and write some of that down, that's a good idea. Now, this is why I defined expression earlier, because it's very important. The things we're about to work with are not equations. They don't have equal signs. We're not solving them, okay? They are types of expressions, okay? Now this up here, that one would count as a polynomial because it's got multiple terms. 2 counts as multiple. Multiple just means more than one, okay? So there's some background knowledge. And we'll jump into working some problems. Alright, now here's something you've done before. 6x plus 2 times, in parentheses, x plus 3. Okay, hopefully this looks really familiar. Hopefully you remember what comes first. We've got parentheses here, and so the very first thing I need to do is take whatever number is outside of it and distribute it to both of the things on the inside. Now, this, not part of the parentheses at all. It gets to stay exactly the same. I've got 2 being multiplied by x. They're both positive, so that's plus 2x. And then I've got a positive 2 multiplied by positive 3. That's plus 6. This is something you answered that you mostly feel pretty confident about, is being able to distribute. Okay? Then I've got a 6x and a 2x. This is also something we've done a lot this year. When you have the same type of term, you can combine them. It's called combining like terms. So you have heard that word term before. Term, again, meaning a piece of an expression or equation. So 6x and 2x both have an x in them. They are like terms. They can be combined, in this case, by adding. When you do combine these, and again, you've been doing this all year, notice that the x never changes. It's the big numbers, the coefficients, that we actually combine. So, an x is a placeholder. It's kind of like if I said 6 marbles plus 2 marbles. That's 8 marbles. The word marbles doesn't change at all, just the number. So 6x plus 2x is 8x. And then this plus 6 over here, it doesn't have an x on it, so it can't be combined. It's going to stay the same. Okay, now again, this is an expression, not an equation, so I can't solve it. That's all I can do. That is my answer. Again, that's hopefully something that looks familiar, that we've done before. Alright, let's jump into something that's new. Alright, I know this is going to look like a lot at first. It's not. Okay, now last week we did some stuff with exponents, okay? So we're used to seeing exponents by now. This one has an exponent of 2, an exponent of 2, an exponent of 3, okay? Now notice these are in parentheses, and so if we had anything out front, which we will get to some of those eventually, we would need to distribute them. However, this one has nothing out front. This one has a plus sign out front, okay? When we are adding these things, we don't need the parentheses. There's no numbers outside. We're adding. I can actually just drop those parentheses real quick. Okay, so really the only thing that needs to be done in this question is combine the like terms. Okay, now, when you are writing an expression after having combined like terms, you want to put them in order from biggest exponent to smallest exponent. Big exponent to small exponent. And then if something doesn't have an exponent at all, it would go at the very end, okay? So I'm looking around, I've got 2 as an exponent, and I've got 3. So the biggest exponent here is 3. I'm going to put that one first. The only thing with an exponent of 3 is this term right here. So that is going to go first. Negative 3p cubed. Okay? So I'm done with everything that has an exponent of 3. Moving along, I see that this one has an exponent of 2, and so does that one. So I need both of them. Here's 1, here's 2. Notice I include the sign with it, because that's important. I've got a positive 5p squared plus 2p squared. Now, just like in the last one I did, it is only the numbers that will change, not the variable, not the exponent, okay? Last week we were multiplying and dividing variables with exponents, and in that case the exponent did change. When you are adding or subtracting, it does not. So, 5p squared plus 2p squared, the only part I'm actually adding is the coefficient, the big number that's in front. 5 plus 2 is positive 7, and p squared stays exactly the same. Now, the only thing I haven't used yet is this minus 3. It's a big number, it doesn't have a variable, there's no exponents involved. It's going to go at the very end. Again, this is an expression, not an equation. There's no solving for me to do. All of the like terms have been combined. For something to be a like term, it must have the same variable and exponent. Both the variable and the exponent have to be exactly the same. So p to the third and p squared, not the same thing because the exponent is not the same. All right. Moving on to something a little bit different. Okay, now what's different about this one is that I have a minus sign. Okay? Now this minus sign changes things a little bit. When there is not a number in front of your parentheses, we need to always remember that we can pretend there's a 1 there. Okay, we could have done that on the last one too. Now, when you just have a positive 1, if you were to distribute a positive 1, nothing would change, which is why we didn't have to change either of them last time. However, right here, this is a negative 1 that I have in front of this parentheses. Therefore, when I distribute it, it will change some things, okay? So if there's a minus sign, you absolutely need to take the time to distribute that negative 1. Negative 1 times 4 is a negative 4 or a minus 4, and negative 1 times 2a squared is negative or minus 2a squared. Okay? All this is doing is just changing whatever sign it used to be. Okay, so if this used to have been a minus, it would change to a plus. Multiplying by negative 1 just changes that sign. So I've got 3a squared plus 1 minus 4 minus 2a squared. Again, I'm looking for the thing with the biggest exponent. The biggest exponent I see is 2, so 3a squared. Also, this minus 2a squared. Now, if I had two terms with the same exponent but different variables, like let's pretend that one was a b squared, I could not combine them because remember, like term means same variable and same exponent, so they would each stay separate. In that case, the terms tend to go in alphabetical order, but that's not something we're going to worry about, okay? I'm not going to be picky on the order as far as that goes. So 3a squared minus 2a squared, I'm only combining the big number out front. 3 minus 2 is 1. The a squared does not change. Now 1a squared is the same thing as just a squared. So you may write the 1 or not. I will totally take it either way. Then we've got a positive 1 and a minus 4. Be careful with minuses and negatives. 1 minus 4 is minus 3. You have calculators hopefully that you may use. If not, Desmos.com is my best recommendation for a calculator. Nothing else can be combined. There's no solving to do, so that is completed. Okay, now you might see some of these with more terms. Okay, maybe you'll have 5 or 6 terms that you need to combine. That's okay, take the exact same steps. Find the biggest exponent first, then the next biggest, then the next biggest, until you're done. Alright, that is the first assignment you will see. Okay, the first assignment, 8.1, adding and subtracting polynomials, that's it. The second one is going to be distributing with polynomials. Okay, so very similar to things we've already done. In fact, honestly, it's just combining two things that you already know how to do. Okay, so for instance, it could look like this. 8x times parentheses 6x plus 3. Okay, again, no equal sign, we don't have to solve. We've got parentheses, so we know distributing is going to be involved. The only difference from what we've done before is that when I distribute 8x times 6x, I'm now multiplying with variables, okay, which is what we did last week. So that's really all that's changed. And then, of course, I'll have to multiply by the 3 as well. So 8x times 6x. This is where those exponent skills are so important. You may not think about exponents because you don't actually see an exponent on either of them, but they're still there. When we don't see an exponent, just like if we don't see a number out front, we can pretend that there is a 1 right here. Alright, so 8x to the first times 6x to the first. I'm just going to start by multiplying the big numbers. 8 times 6 is 48. Then I have x to the first times x to the first. The rule from last week is that you add the exponent. So 1 plus 1, I now have x squared. That is part of why last week's rules were so important. And this one is the most important. When you're multiplying variables that have exponents, the exponents get added. I then take 8x and multiply it by 3. 8 times 3 is plus 24. All I have is this x to the first. There's no other x's, so it will not change. There's my x. Okay. Let's look at another one. Okay, this is a little different because you'll see A's here and you also see a B. Okay, something can have more than one different type of variable, and that's okay. Same idea, I've got parentheses, so I need to take what's on the outside and distribute it or multiply it by everything on the inside. So one step at a time, I've got 10a times a. Start with the number. Okay, this is 10. There's no number here, so I could pretend that it's a 1. 10 times 1 is just 10. And then I've got a times a. Again, you need to think about it. There is technically an exponent of 1 there. So 10 to the first, a to the first times a to the first. If I add those exponents, I get a 2, or a squared. Then I have 10a times minus 10b. Anytime you have a minus sign in between, it goes with what comes after it. It makes it negative. So this is like 10 times negative 10, which is minus or negative 100. Then I have an a being multiplied by a b. Okay, just like last week with the exponents, I can't combine different variables, different letters, so we just write them next to each other. Again, you usually put them in alphabetical order, but I won't be too picky. A does come before B, so A, B. No solving because there's no equal sign, so that is the answer. 10a squared minus 100ab. Alright, a few more to go because this one's really important, so I want to make sure we've really got this one down. This is on your second assignment for the week, the distributing with polynomials. Alright, so I'm going to do one that's got a little bit more going on. Okay, this one has a lot. There's more terms now. There's exponents now, bigger ones. But same idea, I've got something on the outside. I need to distribute it to everything inside the parentheses. Yes, you can distribute to 3 things. So however many things are in the parentheses, you distribute to all of them. So first one, negative 8r squared times 4r squared. Always start with the number, guys. Break things down to little pieces. If nothing else, you can multiply the numbers. Use a calculator if you've got to. Negative 8 times 4 is negative 32. R squared times r squared. This is where last week's rules are so important. The rule is that I add these exponents. So 2 plus 2 This is now r to the 4th. Alright, I've used this one. I'm now moving on to minus 5r. Notice that this minus makes the 5r negative. So I have negative 8 times negative 5, which is positive 40. And then I have r squared times r. This r right here technically has a 1 in the exponent, so when I add 2 plus 1, that's r to the 3rd. Okay, this one is done. I next have negative 8r squared times positive 7p. Okay, so start with the numbers. Negative 8 times 7 is negative 56. Alright, this negative out here was super important. Because I was multiplying by a negative, all of these signs ended up changing, so be careful of things like that. And then I've got an r squared being multiplied by a p. Now I'm not going to add any exponents here because p and r are different letters, different variables. So we do typically put those in alphabetical order. P, r squared, but again, not going to be super picky about the alphabet part. Okay, one more. This is going to combine everything we've just learned. Okay, this is a new question, new example. Okay, you can see that there are parentheses in this question. So before I can do anything else, I need to take care of that by distributing. Now, there are 2 of them. We're going to take care of them one at a time. So in the first one, I've got a 6 out front being multiplied by 2 things inside the parentheses. First is 6 times x to the 3rd. I could think of this as 1x to the 3rd. 6 times 1 is 6. And then this doesn't have any variables, so the variable's not going to change. That's still x to the 3rd. Then I have 6 times negative 3x. Start with the big numbers. 6 times negative 3 is negative 18. And then this one has an x on it, so we're going to keep that. Okay, I'm finished with the first part of distributing. I go over here, and notice this minus sign, that's important. Minus x is being distributed inside the parentheses. Okay, again, the sign in front is super important. That makes this x negative. So, negative x times 2x squared. If I want to put a 1 there, it's really negative 1x. So starting with the numbers, negative 1 times 2 is minus 2. X times x squared. Okay, again, last week's rules, you can pretend there's a 1 here. X to the 1st times x squared. I add the exponents, the 1 and the 2. That is x to the 3rd. Lastly, I distribute the negative 1x to the minus 5, or negative 5. And so negative 1 times negative 5 is positive 5. And then I had an x out here. There's no variable in that one, so I'm going to keep the x. Okay, so all I did was have to distribute twice on 2 different things. Okay, now that I've done so, I need to look through here and see if we have any of these like terms that we just talked about that can be combined. Okay, so I'm looking for the biggest exponent first. Here I see a 3, that is the biggest one. Okay, and look, that one also has a 3. Okay, so those right there, this 6x to the